Okay, so when we have radioactive elements that are decaying, the reason they're decaying is to get to something stable. So eventually, after enough of a sample has decayed, it will be something stable, not radioactive, and it's not going to keep decaying. Um, the half life is something that's different for any different radioactive sample or any different radioactive element. It's the amount of time it takes for half of a sample, a radioactive sample, to decay. So we sometimes write, you see in parentheses there, the T with a one half. It's the time T for half of the sample to decay. And understanding that's important. So a little visual for you. Let's say I had like a pile of something radioactive. Um, and we had 100 grams of it. After a specific amount of time, that sample would end up being half as big. It would only be 50 grams. And however long it took for that process to happen, that's what we would call the half-life. Maybe it's 2 years, maybe it's 3 minutes, maybe it's 187 billion years. It's a specific amount of time. If that specific amount of time, the half-life, happens again, the sample gets half as big again. Now it's only 25 grams. And so you'll see the amount it decreases by changes, but every time a half-life occurs, we end up with half of the substance. So if another half-life happened, whatever that length of time was for the substance, then we'd have 12 and a half grams. And so there are mathematical formulas for this. If you know them and you want to use them, go for it. We do super simple half-life problems in this class. And so I try to teach it in a way where if you don't have that math background, you'll be okay either way. I either suggest drawing a picture like this, unless you know the math and are doing it the math way, or I'll show you a way to organize it in a table. Do whatever works for you. You definitely don't need to do it both ways. So we'll go through a few examples together. Know that whether I gave it to you in grams or I give it to you in percentages, the amount, grams or percent, would decrease by half for every half-life. Okay, so looking at some examples. In this first one, we know we're dealing with an 18-gram sample. So if we're drawing a picture to solve this, that means whatever little pile we start with, we know is 18 grams in terms of its mass. Now, its half-life is 446 years. So the way I draw these in picture form, I always have an arrow representing the half-life, meaning that amount of time has passed. So 446 years later, since that's the half-life, my sample is going to cut in half. 18 cut in half means I have 9 grams. And I don't have to keep drawing a pile, but it's a pile of stuff that's half as big now. And if I were to draw another arrow, it would be another 446 years. That 9 grams would cut down to 4.5 grams, dividing by 2. Now we want to know how much remains after 2,230 years. So every time I cut the sample in half, from 18 to 9, from 9 to 4.5, it takes 446 years. So if I want to see how many arrows am I going to have to draw, how many times am I going to have to cut this in half, I can take the total amount of time divided by how long each half-life is, and that'll tell me the number of half-lives, the number of arrows, the number of dividing by 2. So I can keep drawing this out. Let's see, I've divided by 2 once, a second time. This will be a third time. 4.5 divided by 2 gets me 2.25 grams. Another half-life passes, so we get 1.125 grams. And let's see, that's been 1, 2, 3, 4 half-lives. We need to go one more half-life divided by 2 one more time. We would get 0.5625 grams. And that would be my answer, because I know that if for each of these arrows, that's a half-life, 446 years, it would be 446, 5 times the total amount of time of 2,230 years will have passed, and we know how much of the sample we have left. If you don't like to do so much drawing and so many arrows, we can look at this same problem in a table format. So we can still go through and look at, well, how many half-lives are we going to need? If the whole process is taking 2,230 years, and each half-life is 446. Total time divided by the length of a half-life. That'll tell me that 5 half-lives or 5 divisions of 2 are going to happen. When no time has passed, our amount is 18 grams. That's our starting amount. But we know we're going to divide it by 2 5 times. So after 1 half-life, we have 9 grams. After 2 half-lives, we would have 4.5 grams. Dividing by 2 again, dividing by 2 again, and dividing by 2 again. If you'd rather organize the information in a table like that, you can. Going on to our next example. Similarly, we're starting with a certain amount. So we have 20 grams to start. The half-life in this case is 2.4 minutes. So for every arrow I draw, I know that 2.4 minutes have passed. So after 1 half-life, I would have 10 grams. After another half-life, I would have 5 grams, but let's see how many half-lives I need. In total, I want 7.2 minutes to pass. So 7.2 minutes, my total time, divided by the length of a half-life, 2.4 minutes. That means that 3 half-lives are going to pass, or 3 arrows, or 3 divisions by 2. So 2.4 minutes, another 2.4 minutes, another 2.4 minutes. We must end up with 2.5 grams. One last example for you that might feel a little bit backwards. In this case, we know the starting amount and the ending amount. So we know that 150, we're going to divide it by 2 as many times as we need to until we end up with 18.75 grams. We can't just do 150 divided by 18.75 because the amount that decays changes each time. We're always dividing by 2. So I tell most people, just divide it by 2 in your calculator and keep track of how many times. So I divided by 2 once, that got me 75. Divide by 2 again, that gets me 37.5. Divide by 2 again, that gets me to 18.75. But now I know that that process of going from 150 grams to 18.75 grams took 1, 2, 3 half-lives, 3 divisions of 2. So 3 half-lives. And it tells me in the problem that the whole process takes 200 years. Those 200 years are split evenly over the 3 divisions, over the 3 arrows. So to figure out how long each half-life is, we could take 200 years, the total time, divided by the number of half-lives or the number of arrows. So for time, we can do division. For the amounts, we can't because it's decreasing by 50% each time, and that amount changes. So we get 66.67 years. Try the try problems.